Okay, so we have talked about the different types of stars in our universe. We understand that they have those different classifications based on their color, based on temperature, but they also have other characteristics like size and their luminosity. Today, I want to talk to you specifically about our sun. Okay, so the structure of our sun, and of course, this would apply to any other star that is, of course, similar to the sun or in that main sequence type of phase. There is no solid surface, but it does have an interior and it does have an atmosphere. Now, that interior is broken up into a few different areas. We have the core, the radiative zone, and the convective zone. And we're going to learn about all of those. You'll notice also that there are other features that are part of the sun. We have sunspots, we have prominences, and we will be discussing all of those. Okay, so the core. Now, of course, we know that the sun produces a tremendous amount of energy, and of course, that energy is what heats and lights Earth. That is all done through the process of nuclear fusion, where those hydrogen atoms are fusing into helium. It needs extremely high temperatures, it needs extremely high pressure, and of course, that is all happening in the core of the sun. And those reactions release that energy. Now, that energy heads out to the radiative zone. It is very tightly packed gas, and it can take, which this is a really cool fact, it can take 100,000 years for energy to move through the radiative zone. So think about that energy that we're getting on Earth today. That energy itself could have been created over 100,000 years ago. It's pretty cool. Okay, so after we hit the radiative zone, we get the convection zone. And notice the word convection here. You know how heat is transferred. You learned about this last year. We have conduction, convection, and radiation. So convection, we know that we are setting up these little zones where the cooler, for instance, air rises. It heats up. It sinks back down. And then it heats up. And then it rises, and then it sinks back down. And so that is actually what is happening in that convection zone on the sun. The cooler gases are sinking, they're getting closer to that radiative zone where they are getting that energy that the sun's created, they are moving towards the surface where they are cooling and then sinking back down again. So it is this constant process. Now, the sun actually has what we would consider an atmosphere, which is made up of a few different areas: the photosphere, the chromosphere, and the corona. And you can see those different structures here on our picture of the sun. Okay, so the photosphere, that is the inner layer of the sun's atmosphere. The gases are thick so that they are visible. When you look at a picture of the sun, like the one you're looking at, what you see is the photosphere. That is considered the sun's surface layer. Now, the chromosphere is that sun's middle atmospheric layer. Chromo means color. And at the start and at the end of an eclipse, when either the moon or the earth is moving in front of the sun, that is when we see that chromosphere. And last but not least, the corona. The corona actually extends out into space for millions of kilometers. Corona means crown, and that is actually only visible during a total solar eclipse. Now, as that corona, and you can see that beautiful picture of it, extends into space, it almost looks like these streams. And those are electrically charged particles, and that is what is called the solar wind. Okay, so some of those other features that we can see on the sun. We can see sunspots, prominences, and solar flares. Those sunspots are dark areas on the sun's surface, and believe it or not, those are actually cooler than the gases around them, and that's why they have that different color. Those cooler gases give off less light, and so they look darker. Now, the prominences are these loops, and you can see here in the picture sort of this loop of gas And they actually sometimes link these different areas of sunspots. Oops. And our solar flares. Now, sometimes the loops connect and they can release a huge amount of magnetic energy. The energy heats gas on the sun to millions of degrees, and that gas erupts out into space. And those eruptions are called solar flares. And of course, our solar wind again. That wind is made up of electrically charged particles from the sun. Those flares can increase the solar wind. And when those particles actually will make it to Earth's upper atmosphere. Now, most of our atmosphere can easily block that wind, but there are certain parts of the North and South Pole where those electrical charges can get into the atmosphere, and they create these powerful currents that cause the molecules to glow, and those are the auroras. So you might be familiar with the aurora borealis, and we can see those beautiful almost rainbow effects, those glowing lights in the sky, but again, happening at the North and the South Pole. Okay, and so that covers it for our sun. Wonderful stuff. Hopefully some new things that you've learned there, and I will talk to you all later.